Hi everyone, I am Shayan. I am a senior member of technical staff at Oracle Cloud Infrastructure Product Development team. I work in the data cloud services team, and with majority of my work um, delving into the domain of machine learning. And here we are to discuss and share the knowledge about cognitive services. Cognitive services, as you can see, has grown in the past decade from the starting of analytics to data science using machine learning, and then we have seen a lot of implementation of deep learning in the domain of natural language processing and computer vision. And so this field has been evolving. We have seen a quite a steep curve of evolution in the last decade, but in the coming decade there will be a lot of opportunities that will be open for numerous folks. So it's good to get uh, the hand of this new technology and get ahead of the curve. So let's start with this presentation. As you can see, that the global cognitive services market has a lot of opportunities to offer, and one of the surveys says that the global market of this is expected to reach 34.3 billion US dollars by 2026, with a compound annual growth rate of 38.4%. So in this presentation, we are going to discuss about what are these cognitive services and how these models are being created, and what are the different studies that say about these cognitive services, what are the markets, and what are the different AI and data science breakthroughs that we have seen. We'll not be covering all of them, but few of the key breakthroughs which gave us the viewpoint that how these cognitive services have come into the picture and how these are being implemented in current scenario in different fields. Because we see them in sports, in medicine, in our day-to-day technology life. Further, we will cover on different pillars of cognitive services, which are vision, language, speech, and decision. And further, I will end this presentation with how you can start with this into getting into this domain, understanding what all are the key basics to learn, and which are these courses to go through, which are the few books that you can start up with, and get into this field and get ahead of the curve. Let's start. So what are these cognitive services? These services are basically to empower the technology professionals like us, like any software engineer or developer, to create intelligent applications without knowing the nitty-gritty or very core mathematical details of artificial intelligence. Okay. Like for example, few people who are researchers who want to understand the maths behind that, for them it's very important to understand the underlying maths behind any algorithms that in the domain of machine learning. Similarly, like the algorithms in the domain of problem solving. So if you don't want to know that those mathematical underlying details, then these services will play an important role for you to use the endpoints of those algorithms as services and utilize for your own service. Say for example, you want to do something related to crop detection, and you don't know how to create a object detection based model using convolution neural networks. So you can use a cognitive service which does all the detection tasks for you. The only endpoint that would be provided to you is a training endpoint, a training API, and a predict API. So where you can plug in your where you can put your inputs as parameters, and you can get your output predictions from there. So the next in line is what are these different how we divide these cognitive services. So cognitive services are just like our five sensory organs. Okay, so similarly we have these five different pillars in cognitive services, which are vision, speech, language, text, decision, and search. In this presentation, I will not be covering search because search is itself a very vast topic, and we have already tackled this domain a lot. But obviously, with new technologies coming into the picture, we are still evolving in this domain. Okay, so let's go ahead and explore how these cognitive service model can be implemented in any system. Okay, So you have a data set, say there are internal and external data sets that you have, and on top of it this cognitive workflow will come into the picture, and whatever the output that would be generated, that will enable the professionals, these technology professionals. So being a tech person say for example you are a full stack person who has in-out knowledge of infrastructure but doesn't want to get into the domain of AI, but you want to use AI in your platform. So there this cognitive services comes into the picture, that okay, I don't want to get into the hassle, but I want to use a service which takes this hassle from me, the hassle of analyzing a data, learning the pattern underlying it, and give me some output out of it. That can be a pattern also, that can be some prediction on an unlabeled data set. So this is how the platform centric model of a cognitive service looks like. So let's check about the different studies that have been different studies or surveys, I would say about cognitive services. As I mentioned, the global cognitive service market has been predicted to rise up to $34.3 billion by 2026. It was $1.95 billion in 2017. So you can see that the growth graph would be pretty steep, and it is still growing very fast. So these metrics can tell you that okay, you would like to be in this domain to get so that you don't get left off. Okay, you don't get that fear of missing out, I would say. Okay, then there was IBM study, a global study, that 82% of the business people want to adopt AI, 60% are concerned about the regulatory issues, and 60% people lack these skills. So it's a good time that people who are interested to get into this domain, it's the right time to understand that okay, how these system works and how you can create some disruptive systems which can be helpful in the existing domains. So the cognitive services market actually exist and can help in multiple domains, which specifically includes BFSI, banking, financial sectors, healthcare, retail, IT and telecommunication, education and manufacturing. Then we also see that there are many financial services which are trying to accelerate in the domain of AI. We see that a lot of people in the financial domains have a lot of financial fintech firms have adopted using chatbots, using dialogue systems which are driven by machine learning, and which is actually doing help to them in their domain. Say for example, recently I've seen ICICI Bank and HDFC Bank, they have opened their AI powered WhatsApp bot, where you can use that bot and connect to the ICICI securities, and you can buy shares and sell shares on that basis. So many new things are happening. Here's the cognitive services market, how it will change different like in what domain it will be more effective and which domains it will change. So in technological perspective, I was talking that machine learning, natural language processing and computer vision is that. In service type, we can see that we can open a cloud and web-based APIs. We can have knowledge management, data transformation, cognitive risk intelligence, data integration and cognitive automation, consulting and advisory. So apart from cloud, the rest of the points can be achieved through on-premise systems also, and even through the SaaS-based model in cloud. In the in application area, we can see there are a lot of options where cognitive services will bring change. These are a handful of them. There are many others also. So the handful of them which I have included here are supply chain management, marketing analysis, personalized recommendation, diagnosis and treatment systems, quality management investigation, predictive maintenance, safety and security management. So these are very big terms, and these are very big domains which cater to a big footfall in an organization, and also cater to a big revenue, draws a big revenue for a particular organization. So so you can see that the application area is pretty heavy. So coming to the AI and data science breakthrough. So why I have put this slide of AI and data science breakthrough, because cognitive service has started from the time we realize that okay, we have a lot of data now, we should use these data sets to drive our intelligence, drive our knowledge, and drive our conclusion for different pipelines in our organization. And the better way to show that how these technology is evolving over the course of time are through the breakthroughs in the domain of artificial intelligence, in the field of data science and the field of analytics, which are, you can say, altogether which group to become which altogether group to which group all together to form cognitive services. So first example, we can see goal line technology. Now many people can argue that okay, how come this is a cognitive service? So as I mentioned, what are the 5 pillars of cognitive services? Vision, text, audio, decision, search. So we can see that okay, vision is being used here, which is clear cut benchmark that okay, we are using the image data set here to figure out that okay, is it able to cross the line or not. So goal line technology is one good example in the domain of cognitive services, where specifically we are using computer vision techniques to sort this old debate that whether the 1966 goal done by goal, I guess it was England who won the World Cup, but it was a dispute that the goal by Franz Beckenbauer was allowed or not, something like that. It was. If I'm wrong, then you can correct me later on. Then the next example that we have is AlphaGo. AlphaGo created a big roar in the community of artificial intelligence when it defeated the all-time high-ranked player Lee Sedol, and later it also defeated the world-ranked one KJ. Before going to the conclusion of this event, let's first consider that what is this Chinese game of Go. Go has a complexity of 10 to power 180, which is like more than say billion times the, or I would say not billion times, because the amount of heavenly bodies or amount of stars in the universe is in the order of 10 to power 120, and this Chinese game of Go had a complexity of 10 to power 180. So there's no chance that a deterministic approach can solve this problem. So Google DeepMind used deep reinforcement learning to solve this and create AlphaGo, which defeated Lee Sedol. In the domain of Go, we have seen that there have been multiple developments over the course of time. Like there was Feargo, Pashi, then Zen, Crazy Stone. These were the different computing solutions that were created over the course of time. But AlphaGo was one which was able to defeat a human, and later on, eventually, AlphaGo Zero became the best ever Go player that the world has ever seen. So currently with the achievement that the Go was able to fulfill, then the Google DeepMind researchers tried to solve the complex problems like Alzheimer's in humans. So since they knew that okay, we are able to solve Go, like Go has a complexity of 10 to the power 180, which is very high. So now why cannot we use some less complex problems and try to solve it using deep reinforcement learning, which we will see in coming years that how they are performing in the domain of healthcare using deep reinforcement learning. Now, in the domain of healthcare, we have seen certain deep learning breakthroughs. One was diabetic retinopathy. A couple of surveys happened where majority of the human blindness was figured out to be caused because of the diabetic mellitus, one of the different conditions, severe condition of diabetes, which was causing to affect human eyes and eventually leading to blindness. So the Google Brain team, they formed a pool of ophthalmologists, which was who were given the task to label a significant amount of retinal image data set, which were in the range of over 100k images, and on these images there were a deep learning model was trained. uh, if people who know basics about deep learning, obviously it will be a CNN model, but it will be a very complex convolution architecture that was created in order to achieve this, which included inception based module. uh, and they finally achieved a F1 score of 0.96, which was higher than most of the educated lot of ophthalmologists across the world. So this was a very big discovery in the domain of diabetic retinopathy. Not discovery, I would say breakthrough in this domain, that how deep learning can be used to detect diabetic retinopathy from the retinal images. Then we have Libretus. So the paper of the paper writer of Libretus was the prof from Carnegie Mellon University, Thomas Sondum. He eventually got the best paper award in NIPS, which is the one of the highest honored conference in the domain of artificial intelligence. So this paper was basically catering towards that how we can create a game theory based learn intelligence system which can defeat poker players in a marathon of poker game. Okay, so how it was defined is that they selected 20 top poker players, uh, or I would say no, four best top poker players of the world, and there was a 20-day period where this poker competition happened, and over the course of time the model became intelligent and it was able to surpass all the four players and was able to win and defeat rest of the players on the table. So all the poker enthusiasts, I will definitely say the computers are coming for you. Okay. Then cricket is a very famous game in India, in a few other countries like in Southeast Asia specifically, but we can also see this game is pretty famous in Australia and England. So Hawkeye technology is one thing which is being used in cricket, and eventually we are seeing that this technology is also being used in badminton and tennis across the world. So this Hawkeye technology was is an invention of the last decade only. We haven't seen it before, that the ball tracking or a shuttlecock tracking system has been devised where it can accurately overrule the decision of the on-ground umpire if he or she is wrong. So this was a great boon for the field of sports, and this relief from a lot of misjudgment that the sports were suffering earlier. Next is Moneyball. I guess everyone has seen the movie Moneyball, where Brad Pitt has acted, and Moneyball is which was based on the book that was written by Michael Lewis, and which gave the term sabermetrics. So Moneyball is basically now used in every sports league across the world, across different sports, and this term sabermetrics has been very famous. What it means actually is that given the amount of resources that you have, in term monetary resources you have, what team you must choose, like say for example in baseball, who should be the strikers that you must choose, or which shooters you must choose. Cricket, which batsmen you must choose, or which bowlers you must choose. In similarly in NBA and EPL, what will be the different position players that you must choose, so that you are able to get the best out of the resources that you have put in. So the one of the best example which was given in Moneyball was the Oakland Athletics team, which ended up winning the American League West title. They were in no way to even qualify for the finals or qualify to the quarterfinals, but the team that was being developed using this approach helped them finally win the American League West title. Next, we saw last year Amazon Go going on the floor with no human employee required in the retail store. It was only thing that you require is that you have to get a bag with you. You have to just come in to the Amazon Go store and walk in there, get your stuff, and just walk out. Your amount would be automatically deducted from your Amazon wallet. So this is a very unique, smart retail store that has been developed by Amazon, which is automated retail store, which we were not even thinking that how one day we will be witnessing this also. So tons of infused camera and lot of visual and non-visual inputs were used as a part of the data to accomplish this feat. Kudos Amazon Go. And then again we come back to Google's DeepMind. DeepMind used machine learning algorithm to Google's data centers. So we know that Google has a cloud. Google Cloud is there, and Google itself has a big data centers across the globe where it has to maintain. It has to keep the machines up and down constantly to provide the world its cloud computing solutions, and also keep its systems running. So there's a lot of energy that is involved, and sometimes even if when you don't optimize your machines, there's a lot of loss of energy that happens. So Google DeepMind was able to use machine learning to reduce the amount of energy used for cooling by up to 40%. So say for example how this would have happened, we can't say directly, but you can just put it that okay, if the system is if your particular machine in the data center is being used at a very high capacity, the cooling required should be at its peak. But when that system does not require cooling, that means when that machine is not being utilized, then that cooling system should be put down, should be shut off, or should be put to, so that because it is of no requirement at that point of time. So this pattern was able to was being studied by DeepMind, and they were able to understand this underlying pattern, and they were able to devise an algorithm for that to detect this. So as we discussed earlier also, what are the different cognitive services? Vision, speech, language, decision, and search. So let's start with different vision services. We see there is computer vision, where we see a lot of different image processing techniques which are working on different input data set and providing results. For example, we see human like we take the input of human, and output generates an infrared image by performing the basic transformations on pixel data. We see that you input a land area, and the output is a percentage of vegetation. Then there's the input of a food meal, and the output are the macronutrients or calorie per gram in that food. And we have recently crowd monitoring systems are being used. So these are the certain vision techniques which are being used. Others are custom vision, where you build a classifier to create grades of crops. You have retinal images, as we were discussing, to detect the diabetic retinopathy. Then we have face recognizer, form recognizer, and video indexer. So these are the different basic services that create that forms the pillar of vision based cognitive services. So if a cloud vendor has to create different vision based cognitive services, these should be the base base features which should be there in as a part of the offering. So currently we have many APIs in the field of computer vision, and few of the cloud vendors like Amazon, Microsoft, Google, and IBM, they have been providing object detection, scene detection. So we can see that many of the APIs are being provided by Google, apart from face recognition, person face identification, and food recognition. But there are many other vendors which are providing the other of the worlds. So, and there are few vendors which are still in the pipeline, which will be coming on the way in the coming decade, and who will be posing competition to or on these grounds against these four cloud vendors currently functioning in the market. Similarly, for video processing, as you can see, we have object detection, scene detection, activity detection, facial recognition, facial sentiment analysis, celebrity recognition, text recognition, person tracking on videos, or which is something like crowd monitoring system. Then audio transcription, speaker indexing, keyframe extraction, brand recognition, and many more. Now we can come to the language and text part of the cognitive services. So we have seen chatbots, we have seen question answering systems that are available as of now. So not many of them are backed by machine learning, but these form the preliminary. But the current systems, as we see in customer support, we have chatbots and all. So these are the very basic uh, services which form the pillar of any machine learning backed systems. So say for example chatbots as of now, even if they are not uh, using machine learning, they are at least using basics of natural language processing, where they are able to figure out the entities and trying to respond to you the best possible answers, like in uh, chatbots offered by different banking organizations. Similarly, there are certain chatbots which are being provided by food delivery vendors, like for example Zomato and Swiggy. They give you option based questions where you select the option, and then you are being directed to a particular you are being cornered to a particular issue. And when they are able to figure out, okay, this is the particular issue that you're facing, then they will connect you to a particular customer executive who deals with that particular issue. So these are certain things which are still a part of cognitive services, whether a machine learning or without machine learning, it still forms a part of cognition. So as we were discussing, so we have question answering system where where the problem statement would be something like that. You have a question to ask and you have a context also, and your context is pretty huge. So say for example in financial technologies firms, there are a lot of finance reports, and these finance reports are, each and every reports are around 40 pages or 50 pages long, and in a year each bank fintech firm, someone like Goldman Sachs or Morgan Stanley or JP Morgan Chase, these folks, they publish approximately 50,000 such reports each. Like, so it's in a huge quantity, and you want to search something, or you want to pose a question across those reports. So how you will try to search? You cannot do a control F on that, or you don't even have the database. Even if you create a cumulative data set, you don't know which is the actual answer, because you cannot rely the answer that a machine is giving. So you can so this question answering in the advance in the domain of deep learning and natural language processing has shown good development in the domain of question answering, for example like using end-to-end memory networks, dynamic co-attention networks, and many more. These days reinforcement learning is also being backed up with these memory networks are being backed up using reinforcement learning, which is helping to find a better output compared to the its parent network model. So quite an achievement, and these services can be used as a part. As we can see in Google Cloud Services, there's a question answering module available. Similarly, we have text analytics. Text analytics is something, for example, if you computer cannot understand text. It understand numbers, it understand binaries. But for example, if you want to make someone understand that, okay, what a sentence means, say for example Warsaw is the capital of Poland, so a basic thing would be at least figure out that what are the parts of speech of each and every term. Like for example, Warsaw is a noun, Poland is a noun, capital is a noun. Okay, and there's a relationship between Warsaw and Poland, and the relationship is the capital. So sentence can be structured in a particular form or not, as a start entity and end entity and a relationship between them. So text analytics service must be equipped with approach where it can create a structure out of any sentence that is being passed on as a parameter to it. And and we have a PDF to text approach also. So PDF to text is actually one of the primary service that I guess every banking sector or every healthcare sector wants, because a lot of data is available in their PDF format which is not being processed. If had it been available in form of a table, in form of a database, they would have been able to use that data pretty handily. So there are a lot of consulting firms in the domain of machine learning who are providing this service as of now, but I haven't seen many people are providing this as a product, because people are making it in-house, which is pretty good. But still there is no general approach that you put, because every PDF, every different organization has different type of PDF format available to them. Like for example, someone will have a particular table format, someone will have non-table tabular format and just go for straight words. Some will have two column pages, like a page consisting of two columns. So these are the certain cases where your generic model philosophy will fail, because we perceive text in our way, but the computer does not perceive text the way we feel. So we have to make it learn, or make it follow certain protocols which we can write through conditional statements. We have language translation. As we see, we use language translation every time we travel in different parts of the world, believe it or not, and we use Google Translate always. And we see that this is a very, very important service that is being required. And so with the advancement of deep learning, earlier we used to have so that this actually machine translation was one of the starting project in the field of artificial intelligence. If you remember Alan Turing's Enigma, the movie imitation game, where you see Alan Turing has created a big computer where he is using multiple conditions to decode the Enigma, the code that they are sending. So similarly, for if since I am an Indian, and if I go to France and someone is speaking French, I will not know French. So it's better that I can have a translator. I can not use a human translator to go along with me. I'm not that rich, okay, or neither I'm a government official. So what I can use is, if I have a software which can take the input in a particular language, and I want to output it to a desired language, say which is my known language, then it would be very helpful for me. Okay, so that's why language translation also forms a very key initial offering as a part of cognitive services. And next in the list is text summarizer. As you can see in the example that there are like two sentences in that, and we want to summarize into a single sentence. So how is this possible? First of all, there are two types of summarizer. There's one called abstractive summarizer, and one is called extractive summarizer. So extractive summarizer is not here in the example. Extractive summarizer is basically I will not say it's a topic modeling based approach, but say for example, you have a lot of sentences, you have a lot of words and tokens. You try to figure out some importance of certain tokens or association of some certain tokens, and you get those tokens out. So those tokens or those strings are are summarizing your actual context, actual big context, but they don't follow any grammar or something. So there is no sentence that you have extracted from it. Okay, but on the other hand, abstractive is a deep learning approach which uses a sequence to sequence based learning, where it tries to incorporate a huge chunk of context at one go as an encoder, and tries to decode output of a certain length, where it tries to follow the grammar correctly relative to the extractive, where there is no grammar. So one advantage of getting this text summarizer is that in order to create an in-house text summarizer, there will be a lot of training required for this, because the text data is very unstructured, and you will be needing like 100,000 of pairs to get a very good output from your model. But on the other hand, if a cloud vendor uses open data set and creates this creates a model out of it, and provides third parties as service, then those third party people can use it. Say for example, I want to use it for this, so I use some XYZ cloud vendors text summarizer API, who have trained this on a wiki data set. Say for example, I'm using Oracle Cloud's text summarizer data service, so I will be able to do it without any hassle of labeling my data set. So this is where the cognitive service comes into the play and helps you out without going to the hassle of a trained data set. Okay, even and on the other hand side, even if you want to train a data set and you don't want to get into that architecture design of a neural network or something, there also cognitive services plays the good role. Next we have speech. I guess there's already a lot of time I have taken. I will try to speed up and give an overview on the rest of the slides that I have. So speech, in the domain of speech, the cognitive services first offering should be obviously speech to text and text to speech APIs, speech recognition, where we can recognize specifically the language and what the input is translated to what textual output, and what is the relationship between those entities in the text. So you can say the first task of a speech recognition should be at least to figure out that each and every words that is like the speech to text is happening properly or not, and then through the voice tonality whether you can match the audio to a particular person registered in the database or not. Then we have speech translation, which is obviously an intermediary step of text would be required, where you convert the speech to text, then convert that text to another language, and then again back to a speech. There are multiple speech and text processing APIs provided by different cloud vendors. I will try to move ahead from the slide. I will share this slide in SlideShare so that you guys can, and provide a link of this in the video section below so that you can go through it, and if you have any queries you can post in the comments and give suggestions to me later on. Okay, in the decision we have anomaly detector, content moderator, personalizer. These are all again based on machine learning approach, where you can create a data set where you can say that okay, this type of certain data is anomaly, and you label it and you train it. So again the service comes into the picture where it has already trained itself and knows how to figure out the pattern. So you have to just put in your data to figure out that okay, this is a anomaly or not. In other point of time, there are certain sections where you don't require a supervised approach. There can be a pattern based approach like unsupervised learning, where you can do this anomaly detection. So then we have personalized uses the machine learning approach to discover what action to rank highest in the context. Like we have client application provides a list of possible action with information about them, and it also gives you the information about the context. So personalizer will define that okay, which action to take first. So as a so this is actually a very important service which helps you to order your order as in like to order your priorities of ranks that you have. Like if you have a certain set of ranks and you have to order it in terms of priorities, then you set your you provide these information to the service, and it creates the proper orientation for you. Then we have several cloud machine learning services which are being obviously provided by the Amazon, Microsoft, Google, IBM, and now Oracle Cloud is also coming into the picture, where all these services will be available. So as you can see that you can this is a very starting phase where handful of machine learning algorithms are available. Well, in the coming time we'll see that the number of rows will be like 4 or 5 times in a year or two, where it will where you will have a lot of other options. Like for example, now if you want to use neural networks and all, we create our own TensorFlow PyTorch model in-house and deploy it in cloud and run it, or a cloud has already a model running which is based on these, and you just plug in your data and it provides you the output. But there are also platforms, like for example in the last row we can see there are supported frameworks, different machine learning frameworks available. So you can create your own customized model, deploy it on the go, and use it for your organizational purpose. Coming to the end, how to take it ahead from here. So I want to say that basically Andrew Ng's CS229 is a pioneer to start. It's a pioneer course to start in the domain of machine learning. Then in the field of NLP, similar course has been provided by Christopher Manning. Then in if you have to enter the deep learning domain, then I would suggest the fourth course that is available, CS231, and that is CNN in computer vision by Andre Karpathy. This is the, I would say, the pioneer course in the domain of deep learning, or anything that is related to deep learning and computer vision, because he is covering neural networks from the basics. Like, this course makes you write back propagation, makes you write the function for differential calculus. So this is actually a very fruitful course. It is a time taking course, but it will, if you love maths, this course will definitely be fruitful for you. And then similarly, we have deep learning in NLP, where Richard Socher and Christopher Manning are covering the nitty-gritties in the domain of NLP, where they start with traditional natural language processing courses, which has been covered by in the course which I mentioned, the second point, and then they move ahead to deep learning based approaches, where word embeddings are being used, where RNTN models are being used, where trees are being used, and sequence to sequence model, encoder decoder, how it has been created, and starting phase of attention mechanism in encoder decoder model. Then we have Oxford Deep Learning course by Nando de Freitas. He is also a very famous prof in the domain of deep learning. This course is very highly important if you want to delve into the higher level mathematics in the domain of deep learning. So this course is more sort of on a theoretical perspective rather than a practical perspective. Then rest of the four last are the books in the domain of computer vision, deep learning, and reinforcement learning, which you can go through, and these are which you can go through and enter into this journey of machine learning. Thanks. And if you have any questions, do put in as a comment. I will be definitely helping you.